How to build a model steam engine. Stuart Models Victoria, Part 3. Cleaning up the flywheel. I'm going to split this part about the flywheel into two parts really, and this first part covers the cleaning up of the flywheel. And before I start the cleanup process, which is commonly known as fettling, I'm having a look at the flywheel to see how good it is. And as a rough casting, this is pretty good. It sits in the 4-jaw chuck very evenly. I'm taking it out of the 4-jaw chuck because it needs to go in the vise in the outer part of the workshop for a bit of serious filing. This is quite a nice casting as far as castings go. There isn't too much filing to do, but it's most important to use the right kind of file. I'm using a half round file. I don't want to use a flat file because the edge of the flat file may just accidentally file some flats in the spokes. And a half round file can be easily controlled in your hand, and it's ideal for this job. Against a full-size steam engine flywheel, this is quite delicate. So you've got to be a little bit careful with it. Don't be too heavy-handed with the file. You don't want to file the spokes square, and believe me, it's very easy to do that. To save some time, the video of course is speeded up because I don't want to run it in real time. It would be very tedious watching me carefully filing these spokes at the correct speed. Although I haven't gone too crazy with the speeding up, this is running at double speed. I quite like the sound that the file makes on cast iron. There's something good about filing cast iron. I don't really know why this should be, but it's good. It feels really good under the file. And if you've had a bad day at the office and you're feeling stressed, get your file out and a piece of cast iron and file away. And very soon, everything appears calmer. And it's also kind of satisfying watching the flywheel take shape, getting rid of all these nasty sharp little pieces. Even when using a half round file like this, be very careful with the edge of the file because you do not want to create any grooves anywhere in this part of the flywheel. If you're a complete beginner to this sort of thing, you may find that you make the odd mistake. We all do that. And if you do file a notch in the flywheel, you can always use some filler to fill the notch, because it's going to be painted anyway. And for filler on castings, I really do recommend JB Weld. It's a 2-part epoxy resin mix, but in one of the parts there is some steel, and it's incredibly strong stuff. It's not like car body filler, it really is permanent. And I found it also to be very good for filling castings. When cleaning up or fettling castings, I generally miss part of it, but on this one I've tried to be quite thorough. And at the moment I'm using a piece of belt sander sanding belt to finish off the job. As I was holding the casting in the vise to file it, as you've just seen, it kept moving around, which means that there are some knobbly bits around the edge, so it's a good idea to remove these on the belt sander. I should have done this right at the beginning, before mounting the casting in the vise and starting to file it, but alas I forgot, so I'm doing it now. So we have a totally knobbly free zone around the outer edge of the flywheel, and it's nearly ready for machining. But not yet. I'm now using a small drum sander in my Minicraft drill, and I'm cleaning up the scratch marks left by the file and generally getting any bits that I've missed. It was difficult with some of these flashings right in the corner, and I didn't want to risk filing any notches with the file, but this small Minicraft drill that runs on a 12-volt power supply is absolutely ideal for doing this job when it's fitted with a small drum sander. There are quite a few brands of mini drills out there. I would avoid the really cheap ones that are battery operated. I can recommend Dremel mini drills, they're very good indeed, but I don't have one of those. I've had this Minicraft drill for a long time, and the thing I like about it is it uses a proper chuck. It doesn't have collets, so you're not messing around changing collet sizes for different applications. For any viewers out there who've been following my series, How to Rebuild a Stuart Models 5A Steam Engine, you will realise that I've already covered machining a flywheel in that series, but a Stuart 5A flywheel is very different to this one. It's very big, very heavy and very solid. This flywheel needs a different approach because it's quite lightweight and it's fairly fragile and not quite as solid as a 5A flywheel. All it needs really though is a slightly different approach, and in this clip I'm fitting the flywheel casting into the 4-jaw chuck. When I first fitted the casting and adjusted the chuck, I made a mark at the top to show me which was the top jaw. so I'm putting it back in the same position because it should be somewhere near. Whenever I fit a casting into a chuck, I always tap it with a mallet. And to some viewers, this may seem like a very strange thing to do, so why am I tapping it with a mallet? Two reasons. One is to seat the casting firmly on the individual jaws of the 4-jaw chuck, and also to listen to the tone of it. In days gone by on the railways, and maybe still today, I don't know if they still exist, there were wheel tappers. And not unsurprisingly, the job of a wheel tapper was to tap the wheels of the carriages when the train was in the station using a big hammer, and if the wheels gave a nice ringing sound, all was well. If the wheels gave out a dull sort of thud, then the wheels could be cracked, in which case some further investigation would be required. While I've been talking about wheel tapping, the video on screen has been showing me facing the front of the flywheel rim, and you may have noticed that certain parts of the flywheel casting is not perfectly centred, namely the centre boss and the outer edge. That's because the part I need to be centralised is the inner part of the flywheel, the part between the spokes, the rough cast metal. I can't machine that. So that's the part I need to run true, otherwise it will look stupid when the engine is finished if the inside part of the flywheel is running out of true. I'm turning the flywheel the other way around in the 4-jaw chuck, and the reason for facing the rim like this means that it is now very securely held in the 4 jaws. No knobbly bits or uneven casting against the jaws, just cleanly machined cast iron. And before continuing, I'm just truing up the casting in the 4-jaw chuck, and again tapping it with the mallet. A quick test cut tells me everything's okay, and I'm facing the front boss. Before any experts write in to tell me about specialist tools for speeding up the truing up of things in 4-jaw chucks, I do it this way. I know about wigglers and wobblers, and if you're into things like that, well, why not make a video about it? I have no such machinations of the devil in my workshop. That was a joke, by the way. I find it easy enough to true things up in a 4-jaw chuck without any attachments, and that's because, alas, I'm not a proper engineer, I'm just a poor musician. Generally speaking, first of all I move the lathe tool very close to the work but not touching it. Then I rotate the chuck by hand, and whichever part of the work is nearest to the tool, I move it away a little bit. Then I retighten the jaws, and I repeat this for every jaw on the 4-jaw chuck, and eventually the part runs quite accurately. So I don't need wigglers and wobblers and jigglers and jogglers or whatever they're called. I just do it this way. Right or wrong, it works. Although this episode is called Cleaning Up the Flywheel, there are 1 or 2 machining operations. You've already seen me machine the outer rim of the flywheel, which is now turned round in the chuck and is currently up against the chuck jaws, and in this clip I'm taking the final facing cut across the centre boss. The drawing tells me that the finished dimension for this flywheel is 3/4 of an inch from front to back. And don't forget, I've already machined some of the outer rim on the other side. The absolute last thing I need to do now is to machine lots of metal off this edge of the flywheel. If I did that, the flywheel would be ruined, because the concave part of the cast metal just inside the rim needs to be the same thickness at both sides. So if you're doing this job, keep your eye on that. Don't take too much off one side. Don't be frightened of removing the flywheel from the chuck and remachining some metal off the other side. It is very important from a cosmetic point of view to make sure that both sides of the flywheel are machined equally. And that's it for the moment. Thanks for watching, and I hope you found it useful.